Hello. Let's continue with absolute values of linear function. Alright, absolute value of linear function. So before that, you have to understand that absolute value is defined as the modulus of x as x for x greater or equal 0 and negative x when x less than 0. Alright, and you know that modulus x is also can rewrite as the square root of x squared, right? This is the knowledge when you learn during chapter 2. So now we're going to introduce the second concept here, that modulus of x is actually defined to be a piecewise function of x and negative x when x more or equal 0 and x less than 0. Okay, I'm going to explain why is this happen, right? Is this happen? Because when the number, as you know that the modulus is always positive, right? Modulus always positive. So of any number here is always positive. So when the x is positive, when the x is 0 or positive value, then it for sure is positive, right? So when the x is a negative number, so you have to put a negative to this negative number in order to become positive, right? So it means that it's always positive. So I introduced the graph. Okay, let's say you have y equals to x. You have a function of y equals to x, a linear function, right? A linear function. So you actually can see that x is, as you know that y equals to x, the graph will be always passing through the 0, and the coordinate here all is 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1, right? Which the y and the x value are the x and the y coordinate are the same. So what happened when you modulus, right? You modulus. So when you modulus this graph that are positive, the value of y that are positive, when you modulus, it will always positive. It will be still on the at the same on top here. So but when you modulus the graph here, because why? Because the value of y here all is negative, right? So once you modulus, the graph will be going up. It will be going up. So automatics, it will be everything above the x-axis, right? Above the x-axis. So then from this graph, you actually can explain the modulus function here. So as you see that this is the part of the graph for y equals to x, right? And this is the part of the graph of y equals to negative x. You should know that. So because graph for y equals to x, right? Y equals to x, and right, this is the graph for y equals to negative x, right? So yes, as you see that x more or equals 0, the modulus x function, when x more or equals 0, it will be y equals to x. So when x less than 0, the graph will be y equals to negative x, right? Part of the negative x. So that's why this function is represent this graph here. Alright, this graph here. Alright, let's look at another examples. Okay, let's look at this example. So, and it's the same thing that you have to remember the definition of more absolute values, right? It will be modulus x will be the part of positive x and negative x for x greater or equal 0 and x less than 0. This is a very important concept for modulus function. So as you see that this one modulus x minus 2, you can rewrite as a piecewise function where x minus 2 is defined into two regions. Alright, it's divided into two regions. One is the positive of the x minus 2 and the other one is x minus 2 here. Alright, negative x minus 2. So this one, of course, it will be in the region where x minus 2 will be more or equal 0. We will follow this definition here. So if this is x minus 2, this will be your x minus 2. X minus 2. Negative, this one x minus 2, and this one also x minus 2. Alright, we follow this as a reference for absolute linear function. Alright, so okay, I go for many examples so that you can see. So then, of course, this one is for region where x more equals 0, and this one will be x less than 0, right? Because why? You have to understand. Because when x, this one you were getting what? You were getting x more or equal to, x more or equal to, and this one you will get x less than 2, right? X less than 2. That is very logic. Very logic here is when x more or equal to, when x more or equal to means that 3, 2, 3, 4, 5 and 6. So if you minus, you're getting a positive number, right? So you don't need to put a negative here for this number to become positive, which is the concept of modulus. So when you choose a number that less than 2, for example 1, 0, if you put 1 here, 1 minus 2, right? Without the negative, 1 minus 2, you get negative 1. You put 0, you get negative 2, right? So you have to put a negative value here to make it positive. This is the concept of modulus, where you modulus, it have to be positive. So, okay, this is the function after you write in piecewise form. So now you can sketch the graph. You can sketch the graph. Okay, now we go to the longer way of sketching the graph. We see one by one. Later in the next video, I'm going to show you the simple and easy way in sketching the modulus function graph. So 0. So modulus x minus 2. So means that you have to understand, you have to know how to sketch the linear function y equals to x minus 2. So the graph y equals to x minus 2, as you know that it will be intercept at this is your y-intercept, right? This is your y-intercept, negative 2, and they will intercept x. Intercept x means y0, right? Y-intercept, x equals to, x-intercept, intercept x, y equals to 0. So x minus 2 equals to 0 and x equals to 2. So they will intercept at 2 here. So if you're sketching the graph, it's supposed to be this way. This is the graph for y equals to x minus 2. But once you put a modulus, right? You put a modulus. This is the graph after 2, right? After 2 is positive, it's okay. But before 2, it is the value of y here is negative, right? The coordinate of the y is always negative. So once you put modulus, after this point, the graph that below the x-axis will be reflected. So I'm going to draw here 2. And before 2, so negative 2 will go to 2. So this is the graph. Where's the negative part of y will be going up. So this is also represent this function here. So means that everything here, the V shape here is actually the function x minus 2, the graph for modulus x minus 2. But actually in this graph there are two sections. One is for x after 2, which is y equals to x minus 2. And for this section here that before 2, it will be y equals to negative x minus 2. We use how to explain the modulus function here. So I will give one more example for you. So you can continue or you can try it exercise. Okay, let's look at this example. So fx equals to modulus of 2x plus 1 here. So, okay, I rewrite again. So as you know that the modulus of x is defined as positive x and negative x for different region, right? For x more equals 0, okay, this will be the reference for every modulus function of a linear function, all right? Absolute function. So you see that this one, so you modulus 2x plus 1, all right? Modulus 2x plus 1, so it could be have two function, right? So which will be 2x plus 1, the first one, and the second one will be negative of the 2x plus 1, all right? So it will be positive. This one modulus will be positive, when the 2x plus 1 is actually positive also, right? You see the in front here that is positive, because you don't need to put negative here to make it positive, because this is already positive. Follow this definition here. If this is 2x plus 1, this will be 2x plus 1. This also will be 2x plus 1. So, and you know that from here you can get that after you solving all this, actually you can get x more or equal negative 1 over 2, right? More or equal negative 1 over 2. And for this one, the 2x plus 1, follow this one, the 2x plus 1. The x here have to be less than 0. Okay, less than 0. And after you modify, you will get x less than negative 1 over 2. So if you rewrite modulus of 2x plus 1, it's the same as 2x plus 1 for x greater or equal negative 1 over 2, and negative 2x plus 1 for x less than negative 1 over 2. 1 more than, 1 less than. Right? So this will be the absolute value function. So to sketch the graph here, so you have to refer to this one, okay? So as I tell you just now, I have a shorter way and simple way of sketching the modulus function without overthinking about the concept here. So, but you have to understand the concept so that you study mathematics, right? You really learn the mathematics here. So x 0. So at first you look at this graph here. You have to sketch the graph of y equals to 2x plus 1 first. 2x plus 1. So how was the graph for 2x plus 1? Right? 2x plus 1. So of course they will have y-intercept 1, right? Y-intercept 1, and the x-intercept. X-intercept here, this linear function, the x-intercept here, so means that intercept x, y have to be 0. So 2x plus 1 have to be equals to 0. X equals to negative 1 over 2, right? So from here you have is negative 1 over 2, right? Negative 1 over 2. So when you sketch the graph, it will be a linear function, right? A linear function. So what happened when you put a modulus, right? When you put a modulus. So when you put a modulus, it means that the value of y always positive, right? You see this after negative 1 over 2. After negative 1 over 2, it will be still positive. So we are not modify this graph, is here, right? So but when you put a modulus, the negative part of the graph, which is below the x-axis, which is the negative, it will be reflected, right? So I re-sketching here. So negative 1 over 2. So the graph will be, for this part here, it will be going up, right? It will be going up here. So means that the part here, this is the whole thing is fx equals a modulus of 2x plus 1, and the name here is y equals to 2x plus 1, means consists of two graphs. One is y equals to 2x plus 1, the other y is y equals to negative 2x plus 1, right? So I'm going to introduce you the domain, right? The domain and the range, right? The domain is negative infinity to infinity, or the real number. Why is it? Because anywhere along the x-axis there is a graph, right? So anywhere 2, 3, 4, 5, negative 1, negative 2, negative 3, there is a graph. If you draw, it will never stop. So it's everywhere along the x-axis there is a graph. So that's why you have negative. But range, you see the y value here. They only have positive y value, right? Of course, because why? Modulus 2x will be at least 0. Is the most also this one will be 0, right? Modulus of something can be 0. Modulus at least 0 or positive number, and the y also must be positive, right? So if you base on the graph, you see that the graph is above the line y equals to 0, right? So then you know that the range is close, include the 0 up to infinity, right? Up to infinity. Alright, I think I have explained you for the concept of modulus absolute value function. So for now, I'm going for the next video for how to sketch an absolute value linear function in an easier way.